Welcome to the Tech Talks Daily Podcast, where you can learn and be inspired by real-world examples of how technology is transforming businesses and reshaping industries in a language everyone can understand. Here is your host, Neil C. Hughes.
Welcome back to the Tech Talks Daily Podcast. Now, there is a growing hype around quantum computing at the moment, and often some businesses are accused of exaggerating the capabilities of quantum computing, and many aspects of the media are reporting the best case scenarios of the future as the facts right here, right now. But there is so much progress being made in quantum computing at the moment, and one company leading the way is Quantinuum. So today I've invited Jenni Strabley and Simon McAdams of Quantinuum onto the podcast to talk about how Quantinuum is the largest full-stack quantum computing company, but more importantly than that, talk about their new quantum chemistry platform called InQuanto. And InQuanto is trying to make it easier to explore and experiment with quantum computing, and offering a path to rapid and cost-effective development of new molecules and materials, which in turn could generate novel answers to some of the biggest challenges we face in things like sustainability, climate change, drug discovery, and so much more. So InQuanto was developed by Quantinuum's quantum chemistry team to support collaborations with big-name partners such as BMW, JSR, Nippon Steel, TotalEnergies, and so many more. But through collaborations like this, InQuanto has already led to the achievement of a number of firsts. But what are those firsts? How did they get there? And what is the future of this technology, and how will it be used? Well, buckle up and hold on tight, because I'm going to beam your ears simultaneously to the UK and the US, where we're going to talk about all this and much more. So a massive warm welcome to the show, both of you. So can you tell the listeners a little about who you are and what you do? And Simon, I'll let you go first.
Hi Neil, thanks for having us. My name is Simon McAdams. I am the quantum chemistry product lead here at Quantinuum. I actually joined the company about 3 years ago. I'm a sort of legacy Cambridge Quantum employee. So Cambridge Quantum, back in 2019, was a software company that developed software that leveraged today's quantum computers for different applications. We worked very closely with a company called Honeywell Quantum Solutions, which was a division of Honeywell, and they built quantum computers. So they built ion trap devices. And back in December last year, the two companies merged to form Quantinuum. And now we are one of the largest full-stack quantum computing companies in the world. So I work very closely with our quantum chemists, and we have developed a product called InQuanto, which we will speak about later today.
Fantastic. And we're also very fortunate to have Jenni joining us today, all the way from the US. So, Jenni, can you tell everyone listening a little about you too?
Hi, thanks for having me. My name is Jenni Strabley. I'm the Senior Director of Offering and Program Management for Quantinuum. So I'm sort of the counterpart of Simon, that I came from the legacy Honeywell Quantum Solutions business, which was the hardware business. But now, as part of Quantinuum, oversee the products that we release, most of the products, I should say, that we release. And happy to be here, happy to be talking about Quantinuum and InQuanto today.
Fantastic. And Quantinuum is known as the largest full-stack quantum computing company. And in fact, on this podcast, your CEO and co-founder shared the inspirational origin story behind the company and being inspired by Stephen Hawking. But if anyone that missed that previous interview, can you just remind everyone listening, Jenni, with a little more about the kind of problems that you're solving at Quantinuum with technology?
Sure. So Simon walked through what Quantinuum is and how it became, and sort of the timeline. Still a new company, only about 6 or 7 months old. But as Simon said, both companies worked together prior to the merger, so had a lot of connections already. Now, as this new company, what we're focusing on is integrated solutions. So that means really having solutions that work across our current hardware, the H-series quantum computers, but also we're hardware inclusive. So we work across other hardwares in the quantum realm. So the types of software, the types of applications we're working on are cybersecurity, and hoping to come back to that at the end of a little bit later to talk a little bit about our cyber products. We also work on applications that would make use of artificial intelligence or machine learning that would be implemented on quantum computers. Also, different types of algorithms that go into the nearly related to those. We have a team that works on natural language processing, and again, how you can use quantum computer to do those types of things better. We have a team that works on, I'll say, middleware, so sort of the middle sections of the stack between the algorithms and the hardware. So these are development kits, development toolkits. One that we have open source is called Ticket. And then, of course, chemistry, which Simon is going to represent today. It's kind of the suite of areas where we work. We have two products today that are the Quantum Origin, which is our cyber product, and then InQuanto, our new chemistry product. And I should say for all your listeners that what we're doing today is really investigating and helping other people investigate how can they use quantum in their business, in their workflow. Quantum computing is still a development. We're still working on getting the hardware to the point where it can do these industrial relevant things. But as that hardware is coming along, we're introducing these tools and doing research along with industrial partners to help us understand what are the necessary things that people need, but also to help those companies understand how will they be able to leverage quantum in the future.
Thanks so much, Jenni. And you did mention there that you guys have also recently released a new quantum chemistry platform. So, Simon, can you tell me a little bit more about that announcement?
Sure thing. So this package is called InQuanto, and it's a piece of software that allows users to perform quantum chemistry calculations, but on quantum computers. So InQuanto has been in development now for a number of years to support our industrial collaborations with various partners from across various industries. And it really allows them to start to tackle industrially relevant problems on today's quantum devices. Now, of course, you can't do anything today on a quantum computer that you can't do with a regular computer, but that's not the point of InQuanto. The point of InQuanto is it allows users to start to understand the capabilities of today's quantum computers and to start to develop methodologies in tandem with the evolving hardware. So when the hardware does evolve to a certain point, you can apply those methodologies and actually solve real-world problems on real quantum computers.
And I also read that it could actually help scientists explore novel approaches to answering some of the biggest challenges that we're facing right now, especially around sustainability, climate change, and drug discovery, to name but a few. But do you have any use cases that you could share that would just help listeners understand how that might work in their world?
Sure. So I should start by saying that quantum computers aren't a magic bullet that's going to solve all of the world's problems. Quantum computers actually solve very specific problems. One of the most famous examples is finding the prime factors of very large numbers, which underpins much of modern day cybersecurity. That's called Shor's algorithm. The other thing that quantum computers could do very well is simulate quantum mechanical systems. So you've probably heard the quote from Professor Richard Feynman, or to paraphrase him, if you want to simulate a quantum mechanical system, you should use a quantum computer. And that will be the other thing that quantum computers will be good at. So with quantum computers, they promise to be able to simulate very large quantum mechanical systems to exact levels of accuracies. So today, if you want to simulate a quantum mechanical system to an exact level of accuracy, you're looking at simulating 20 electrons, which isn't very large. A small molecule drug like aspirin has about 20 atoms, never mind just 20 electrons. So there must be a better way, and that's the promise of quantum computers, that you could simulate much, much larger systems than you can today. And this would have a tremendous impact in the way that we design new molecules and new materials. We are working with major oil and gas companies looking at simulating metal organic frameworks for carbon capture. We're working with a major automotive company looking at a particular reaction within hydrogen fuel cells and trying to use quantum computers to model that. We're working with drug companies looking at quantifying the interaction energy between small molecules and their target proteins. So we can actually start to look at real world problems on today's quantum devices. Of course, they are suitably scaled in such a way that we can actually run them on today's noisy quantum devices. But nevertheless, we're starting to make the first steps towards solving these, major problems using quantum devices.
And Jenni, apologies to put you on the spot here, but are you able to discuss the collaborations and partnerships that you're exploring at the moment?
I'll talk about them in broad terms. I'm not going to go into names, but really what we're looking for is continued learning and developing of InQuanto with very close partnership with the leading subject matter experts. So I think that is where that's where a lot can be done is teaming with Quantinuum and the subject matter experts in these different domains to help that we understand your workflow, the problems that they have. Also, then it helps the subject matter experts get a taste for what is quantum, what is the value of quantum, and together, we can work these problems sort of shoulder to shoulder. And that was the genesis of InQuanto, was doing a lot of these early, we call them development efforts, shoulder to shoulder with industry leaders, and then starting to see that there's a core set of algorithms, of problems that are common amongst a lot of these verticals, starting to group them, starting to reuse them, start to productize them. Ultimately, that collection, after a lot of work, was put out into the market as InQuanto. And then also of increased interest is companies that might be interested in seeing if quantum can help with environmental sustainability problems. So we're seeing more and more companies starting to look at, is there what innovations can we bring to environmental sustainability? And then, of course, those are very challenging problems. And so it's natural to start looking what other tools can help those companies that are looking at environmental sustainability problems. Those are difficult problems. It's going to require a lot of innovation. It's natural that they're going to be looking what other tools can help them. And quantum is one of those tools that they're starting to look at as quantum matures. Is there something that can be applied from quantum to help them develop those sustainability materials or sustainability techniques? So that's a growing area and a lot of interest. And of course, that's something we're all very interested in, because if we can find a good mix there, it will have a very big impact on a growing problem that we're all really coming to grips with around the world.
And I know behind the scenes you're working with some pretty big names. I'm not going to ask you to name any of them today for obvious reasons, but it's also very early days for you guys. But can you tell me more about how these collaborations and partnerships are helping you deliver scientific progress? Are there any examples around the kind of scientific progress that you're making there by working together with partners?
So we've made several breakthroughs. I can talk about on the software and algorithms side that we've done with our partners. One paper that we had with a major steel company in Japan, we were looking at simulating iron crystals on today's quantum devices, and even if we simplified that model, it was actually still difficult to get decent results when running them on an actual quantum device. So we developed an error mitigation technique. So this technique was what we call a post-processing technique. So once you get your results back from the quantum computer, you could apply this post-processing technique. And if any of your results, any of your shots that you ran on your quantum computer violated certain symmetry constraints, they could be discarded. And this essentially helped us remove some of that device noise and actually get very good results. So this error mitigation technique is now incorporated into our InQuanto platform, and it means users can now mix and match different algorithms with that error mitigation techniques to actually get usable results from today's quantum devices. Another area that we've been looking at is something called embedding or fragmentation, where we can take relatively complex systems like a large material or a large molecule that could have tens or hundreds of atoms in it, and we can take that and we can break it down into smaller fragments, and that means we can tackle these large systems on today's quantum devices. And I can talk about more specifics on the work that we've done with a certain oil and gas company around this work. So work that we've done with Honeywell PMT, we looked at simulating a reaction between the methane molecule and a simple atmospheric radical. This is of importance because methane, as we know, is a greenhouse gas, one of the major greenhouse gases. And it's also a very simple refrigerant. And this project was looking at developing novel refrigerants, or the potential for quantum computers to develop and design novel refrigerants in the future. And we found a way to take the methane molecule, which is, relatively complex again. You would require about 16 qubits to simulate this. We found a way to reduce this to only about 4 qubits. And again, it meant we could simulate this molecule on a real quantum device.
And in a paper published with TotalEnergies, I think it was, I also read that it is used to model metal organic frameworks for carbon capture. Now, this is such a hot topic at the moment. So can you tell me more about that paper for anyone that's not seen it?
Sure thing. So metal organic frameworks, they are a family of highly porous nanomaterials that can capture certain gases depending on the chemical makeup of the metal organic framework. So you could capture things like hydrogen, for example, or in this case, CO2. Now, these are very large, complex structures. If you want to simulate them accurately, it's very challenging using today's classical computers. TotalEnergies has their own supercomputer that would struggle to do this. Hence why TotalEnergies is interested in the potential for quantum computing to solve to simulate these large, complex structures. Now, this type of structure, these metal organic frameworks, have never been simulated before on a quantum device. So we wanted to see whether we could do that. So what we did here was employ those embedding or fragmentation techniques that I had mentioned before. So we take the large metal organic framework. Even if we break a piece away from that, that piece contains about 40 or 50 atoms. That in itself is still too complex to model. But what we can do is that we can model the sort of the active site, or the key site, if you like, of this fragment. So this is where the CO2 molecule actually binds to the metal center. So we can actually model the CO2 molecule and this metal center. We model that using a quantum device, and then we model the rest of the fragment, if you like, to some classical approximation using some classical algorithms. And doing this, it meant that we could simulate this system using a simulator for quantum computers. So instead of needing about 240 qubits, we only needed between 4 and 16 qubits to actually simulate this type of system. This was done, as I mentioned, on a simulator of quantum computers. And in the future, we hope to actually do this on a real quantum device.
And it does feel an incredibly exciting space at the moment as we all collectively explore the art of the possible and navigate uncharted waters. So I'm going to ask you both to look into the future a little here at the kind of opportunities available. And Jenni, to begin with, what excites you about the potential of quantum technology?
Yeah, I'll go back to something I said earlier, which is where I think the real benefit can come is, and where we'll see it is folks like Simon and the larger team at Quantinuum, again, penetrating and working in with these subject matter experts across all these different verticals to really start to understand what are the problems. How would quantum get into their workflow? So it's a tool that they can adopt and use in their product development, and then start to see those patterns and collect them and continue to use this mentality to develop and release products. That's, as the product leader, that's what I'm most excited in. But then there's also a huge area of continued research, continued development, continued engineering that's very exciting. And I think that's going to look like continued work on reducing the noise of the qubits, but also correcting their errors, and then continuing to scale up these quantum devices and seeing the algorithms come right alongside them to be able to make better use of these emerging hardware capabilities.
Absolutely love that. And Simon, what about you? What excites you about where we're heading?
Yeah, I think something similar to Jenni. On the software front, it will be good to get the feedback from the users of InQuanto that are using it for the first time outside of these R&D type collaborations. Look forward to further learning what their problems are, and we can incorporate those solutions into InQuanto in the future. On the hardware front, it's very exciting to see the new devices that are coming out and that are on the horizon. We look forward to applying those or using those devices to tackle chemistry problems and see what we can do with these new devices.
And I appreciate you probably can't share too much with me, but just for anyone listening to leave them on somewhat of a teaser, what's next for Quantinuum and what's your big focus right now?
Yeah, I'll take that one. We're still a very new company, only 6 or 7 months together as a company. But one of the things I think we've all been very locked in on is maintaining some very clear focuses about how we're going to proceed in the future and what are both near term and midterm and long term priorities. Say our focuses right now are very, very, very clear and threefold. First is to help people with their cybersecurity solutions. And I mentioned that at the beginning when I gave a bit of an overview of Quantinuum. One of our product areas is in cybersecurity solutions. We have a product called Quantum Origin, which exists, a product that exists today that can take advantage of something a quantum computer can do better than a classical computer. And that is creating entropy through the randomness of quantum. Those entropy can then be used to generate keys, cryptographic keys that can be used in a lot of different applications. The timing for this is really great because your listeners might have heard that NIST has released their guidance on their new encryption algorithms for post-quantum encryption. So when people start thinking about their new cybersecurity solutions, they now have the post-quantum encryption algorithms from NIST, and they have Quantum Origin for generating those keys. And it really starts to become a full solution, full recipe for a future cybersecurity approach. So that's one. Number two is continuing to do what Simon and his team have done so well, which is helping industries and developers to understand the capabilities of quantum computing and how they can bring them to their business. Over and over, that's what we hear people want, is that help in understanding what can quantum do for them. And for those to understand, there has to be a do in this. And that's where we come in, is to help customers with the do. And I think InQuanto is a great example of that and is a great model that will continue as we develop other products that help companies with the do, which is the necessary part of understanding and then using. And then the final piece of focus is on advancing the hardware as quickly as possible. So important to not forget that we continue to develop our H-series quantum computers, which are trapped ion-based quantum computers. And today we deliver that to customers and to our internal users, such as Simon's team. And today it looks like getting these high performance, very flexible devices into the hands of the developers. We focus on quality counts, that every time developers use our machine, they get consistently high performance out of our hardware. And then there's also a lot of R&D going on that we don't talk too much about, but to really do that engineering and the development for our next generation hardware, which will be the next steps towards greater and greater applicability of quantum technologies.
Well, I've loved chatting with you both today, and it's such an exciting space to be in. But before I let you go, I always like to have a bit of fun with my guests and ask them to leave everyone listening with a little note, a personal note of inspiration. So I'm going to ask you both, can you leave us with a book that has inspired you that I can add to an Amazon wish list, or a song that I can add to a Spotify playlist? All I ask is you give me a little story behind whatever it is you choose. And Simon, we'll begin with you on this one.
Sure. So I actually looked at your book list, and you already have the book that I would have recommended. So I'm going to try the song, if that's okay.
Sure.
I had a look through your Spotify playlist, and I saw that I couldn't find any Iron Maiden. And Iron Maiden's one of my favorite bands, so I thought I'd give you an Iron Maiden song. I recently discovered Iron Maiden, actually when I first joined Cambridge Quantum, and I've kind of been listening to it ever since, especially when working from home. I've always got it on in the background. So for the last few days, I've been trying to shoehorn quantum computing into an Iron Maiden song and see if there's one I could choose. And people always say quantum computing, or the development of quantum computing, is more like a marathon rather than a sprint. So I've chosen a song called "The Loneliness of the Long Distance Runner" from Iron Maiden's album "Somewhere in Time." And it's a great song. It's one that I listen to when I'm working. And hope your listeners enjoy it.
Awesome choice. I'll add that to Spotify playlist. And I did see Bruce Dickinson at a tech conference giving a keynote about entrepreneurship, innovation, etc. He was the most captivating speaker of the whole event. It blew me away. It was absolutely fantastic. So if ever you get a chance to see him away from that, the music, and doing a keynote, is well worth checking out. And Jenni, over to you. What would you leave everyone listening?
I wish you would have asked me first, because Simon's selection is a really hard act to follow.
Yeah.
But actually, I'm going to go a completely different direction. And I didn't look at your book list, so it might already be there. But a book that I've read in the last handful of years that's had a big impact on me is a book called Bad Blood: The Secrets and Lies of Silicon Valley Startup by John Carreyrou. I hope I'm saying his last name right. He's a Wall Street Journal investigative reporter, and the story was about Theranos, which was a startup in the bio industry. And number one, it's very well written. It's a really easy read and a great audiobook if you're listening to it. But it really drives home the value of business ethics, and that's a topic that I'm very, very interested in. And I've always worked with companies that ethics is at their core. And so I realized after reading that book that it's something I completely take for granted, how critical it is to have business ethics at the core of your company. And so to me, this book was an eye-opener about things that can go wrong when business ethics is not at the core of the company. And these cases are making their way through the courts. So I'll leave those opinions to form. But I think that was one of John's points writing the book, was just to draw out that sometimes business ethics is sometimes just taken for granted, and to draw out just the value that employees feel when business ethics is brought to the center and to the core of a company.
Awesome. I'll be checking that out. I don't think that's on our list, so I'll be checking that out and I'll add it there. And obviously we've talked a lot today about InQuanto and Quantinuum, and there's going to be a lot of people listening just wanting to find out a little bit more information, or maybe even contact your team. And I appreciate it's a pretty big website and there's so many different domain names out there now. So could you just point the listeners to the best starting place for everything?
Of course, www.quantinuum.com. Quantinuum is a little bit tricky to spell, so it might be in the podcast. Otherwise, start with Quant, QUANTINUUM. So Quantinuum.com will take you to our website, and you can read about InQuanto. You can read about our hardware. You can read about Ticket. You can read about the other things we're working on, Quantum Origin, and meet some of the people that make up our really great organization.
Well, it's such an exciting space to be in at the moment, so I will make sure that URL is in the show notes so people can find you nice and easily. And one of the most exciting things about InQuanto, of course, is how it's making it easier to explore and experiment with quantum computing. And like I said, as we all collectively explore the art of the possible, I think an interesting few months ahead and years ahead. So I'll be staying in touch with you. It'd be great to follow that progress and maybe get you back on next year, see how things are going. But more than anything, Simon, Jenni, just a big thank you for sharing it with me today.
Thank you.
Yeah, it was a pleasure. Thanks.
What I find incredibly exciting is just the subject of quantum computing. And it was always something that is years in the future. And one day this might be able to happen. But of course, now we're exploring the art of the possible, and new scenarios and new use cases for this technology is coming to life every single day. So it's something that I'm going to be following very closely. But I'm curious, what interests you about quantum computing, and what excites you about this new quantum chemistry platform, InQuanto? Whatever it is, please, I'd love to hear your thoughts, your questions. If you've got any strong opinions you'd like to come on here and share your opinions with me, please do that too. Just email me, techblogwriter@outlook.com. My website is techblogwriter.co.uk, where you'll find links to all the social channels and how you can work with me too. But that's it for today. So a big thank you for listening as always. And until next time, don't be a stranger.
Thank you for listening to the Tech Talks Daily Podcast with Neil C. Hughes. Remember, technology works best when it brings people together.